Okay, this is the lecture video for MAC 1140 pre-calculus. We're in section 10.3 where we take a look at the definitions, theorems, and applications of a conic section called the ellipse. Let's begin by reviewing the definition for ellipse. An ellipse is the collection of all points in a plane, the sum of whose distances from two fixed points called the foci is a constant. Meaning that no matter which point you stand on the rim of this ellipse, if the distance is measured to each focus, the plural of that is called foci, so you are now studying a conic section that has more than one focus, and thus we're going to use the plural foci. So if you were to measure from the point that you're standing on, regardless of where you stand, if you measure the distance to each focus and then sum those together, you get the same number each time, no matter what point you're standing on. The line containing the foci, just so you can understand as we work these problems, these are the various definitions that are going to apply. The line segment containing the foci is called the major axis. So from here to here is the major axis, in other words, the longer axis. Notice that one axis for this ellipse is shorter and the other one is longer. So the major axis is the longer one and the foci are always on the major axis. The midpoint of the line joining the two foci is called the center. So this point right here is called the center, and this is the line segment that joins them. Okay, the line through the center and perpendicular to the major axis is called the minor axis. So from here to here, you're talking the minor axis. And then the longer axis from here to here, that's called the major axis. Okay, moving on. Our first theorem concerning an ellipse is how to get the equation of an ellipse. Now we're first going to look at an ellipse whose center is at the origin. Major axis along the x-axis. You're going to see that there are three specific values concerning an ellipse. There's an a squared value, a b squared value, and a c value. And you are constantly going to be looking to calculate one of those values in most of the problems that you're going to be doing in this section. I want you to notice that the a squared value that you see in this equation here is always the bigger of the two values, a squared and b squared. The a squared value will always be under the major axis. So it'll be the denominator, because notice that the a squared and the b squared play the role of the denominators. So the a squared value will always be the denominator of the major axis, which is why you're seeing the comment right under the theorem that the major axis is the x-axis, because if you look here, you see that a squared is under the x expression. It belongs to the x expression, and therefore that depicts the x. That just means that the major axis is the x-axis. When we start to take these ellipses and shift them away from the origin, shift the center away from the origin, then we'll just say the major axis is parallel to the x-axis. But right now you have your center at the origin, and the major axis in this, for this particular formula or equation, is x squared over a squared plus y squared over b squared. B squared will always be the denominator of the minor axis. Okay, so a squared is associated with the longer axis, b squared is associated with the shorter axis. Okay, so this is a picture. I want to point out some things on this diagram. Notice that again, as we mentioned before, you have your major axis being the longer axis. Notice that both of the foci are located on the major axis. And this was one thing that we have to get very familiar with as we work with ellipses. That if you move from the center out to either one of the foci, that distance is called C. Whereas the distance from the center out to the edge, where you reach what's called the vertices, on either end of the major axis, you will have what's called the vertices. And you're going to constantly be looking for those. So distance associated with either one of the vertices. These are called covertices. So you're going to be looking for the vertices on the major axis so that you can get the A value. And that will be from center out to the edge or center out to the other edge where the other vertex is. Okay, so we've looked at C and B. Then if you want to calculate the missing value, once you have the C and the A value, then you can use this equation right here, and this will be you'll keep the equation in this form every time you go to look for one of those missing values. Sometimes they'll give you a way of finding B, the distance from the center out to the edge on the minor axis. That distance is called B. They're going to give you a way to find two of these three values right here, and you will find the third one using this formula. So you need to memorize this formula as well, that A, B, and C are associated in this manner. B squared is equal to A squared minus C squared. Regardless of which two they give you, you will use it in this form and solve for the missing value. Okay, so we just looked at the equation of an ellipse, being that the major axis is the x-axis. We also looked at a diagram that shows what the distance C is, what the distance B is from center to the edge on the minor axis, and what the distance from the center out to the edge of the ellipse on the major axis. That would be your A value. Okay, moving on. We have the theorem and the equation of an ellipse, where the major axis is now the y-axis. Notice that instead of the a squared being under the x expression, notice that it is now associated with the y expression. And that just tells you, as I stated earlier, right up here, a squared tells you which axis is going to be the major axis. So when you see the a squared under the y expression, that means that the y-axis is longer, or it is the major axis. Again, the foci are always located on the major axis. So this would be one of the foci, this point right here. Foci are points. This would be the other one. You could call it foci 1 and foci 2. But you're actually going to be giving the coordinates. The distance from the center of the ellipse out to the foci is always called the distance C. The distance from the center out to the edge of the ellipse on the minor axis is always called B. And then the distance from the center all the way out to the edge on the major axis is called A. And they're trying to show you how it relates to a right triangle. But this, you can look at this also as A. Okay, distance from center all the way out to the edge of the ellipse on the major axis is the A value. Okay, so again, you see that you'd be using the same formula in order to find one of the three missing values. given at least 2 of them. Okay, let's move on to problems. And one more set of formulas. Okay, these are all the formulas just in case you have an ellipse that has been shifted away from the origin. You notice that instead of just x squared over a squared and y squared over b squared, okay, you're still looking at the major axis here being the x-axis. Okay, and it even says here, major axis is parallel to the x-axis. We can't actually say it's the x-axis like we did on the previous page because you no longer have the center of the ellipse at the origin. So it's been shifted away. But look at these formulas. They're just like what you saw on the last page, except for you're going to see the shift right here. So instead of x squared, it's x minus h, and you would switch this sign and pull it out as the h value at the center. And you would pull this value out. When you pull these values out, because there are minus signs in these formulas, when you pull these values out, you have to switch the signs. And that is true of any formula that has a minus before a value that you're taking out of the equation for graphing purposes. So instead of x squared, it's x minus h. Instead of y squared, it's y minus k. A squared is associated with the x expression, therefore major axis is parallel to the x-axis. Then this is when the major axis is parallel to the y-axis. Okay, major axis is vertical. Be x minus h squared. This time the b squared associated with the minor axis is under the x expression, while the a squared is underneath the y expression. So therefore this the major axis is vertical. Okay, so let's start doing the problems. As usual, you start in my math lab with them extracting your knowledge of the definitions and some of the theorems and the formulas. There's always those kind of problems, and then you actually break into the real problems. So, very first example, example 1, just tries to see if you understand the definition you saw on the previous page. An ellipse, right in there, is a collection of all points in the plane, the sum of whose distances from 2 fixed points, and we've discussed that those are the foci, is a constant. That's just a reiteration of the definition of an ellipse given on the very first page. Example 2, for an ellipse, the foci lie on a line called the major axis. They are always on the longer axis. Okay, example 3, we're going to actually start graphing, lots of graphing in this section. Okay, so for the ellipse, x squared over 4, y squared. Now notice that you don't have x minus anything squared or y minus anything squared. That means that this is center at the origin. Otherwise, you would see expressions that would say x minus something and y minus something before the square was attached. Notice that the larger denominator is associated with the y expression. Therefore, it is going to be longer in the vertical, on your vertical axis, on your y-axis. So this is actually the a squared value, and this is the b squared value. The a squared value is always the bigger value. And it depicts the fact that this is going to be the major axis, the y-axis. Okay, so when you're graphing these, very easy. If a squared is 25, that means that a is 5. Just take the square root of that number. If b squared is 4, that would mean that b is 2. And so if you want to graph this ellipse, all you have to do is move out from the origin. You graph your center first. And on the y-axis, you would move, again, this 5 is associated with the y-axis. You would move 5 up, 5 down. So 1, 2, 3, 4, 5. plot a point, and then you would move down 5. 1, 2, 3, 4, 5. And then the value, that the distance that you're going to move on the x-axis would be 2. So 1, 2. And then you connect these outer points. The center is just graphed first, so you can use that as home base in order to move your A and your B distance. So that would be a graph. Then it says, what are the vertices? So what you have to remember is the vertices are the endpoints of the major axis. They're always the endpoints of the major axis. Now I know that you can just look at the graph and tell what the endpoints are. I'm aware of that, and that would be super easy, but I'm going to, reinforce a technique that's going to allow you to find these answers, foci, vertices, any kind of points that they're asking you for that are judged based on the center of the ellipse. I'm going to do it using a technique that will allow you to continue to be able to give these answers even when there is radicals and fractions involved. And it's not so easy to see them on the graph. So you need something that's going to handle the easiest cases all the way to the hardest cases. So if you're at the center, I'm going to lower this just a little bit. Your center, you already know, is 0, 0. You're trying to get to the vertices, which are these endpoints. So you have to practice understanding, just like we did in the last section, when I'm moving up and down, what coordinate am I impacting? You are impacting the y coordinate whenever you're moving up or down. So if you're moving up, you're going to add whatever the a value is. Remember, major axis is the y-axis. It is associated with a distance called a. That distance is 5. So when I say that I'm moving up a units, I'm moving 5 units up. And I'm doing it just on the y coordinate. Here I'm writing it as a formula. Here I'm writing it with numbers. So one of your vertices would be leave the x alone, but impact your y coordinate by adding 5. Okay, so that would be one of your vertices. And then the other vertice would just be, whenever you're moving down, it is the y coordinate minus the number of spaces, and the number of spaces is called a. As a number, it is called 5. So your other vertex would be leave the x alone but impact the y. So this y was 0, and if I'm going to subtract 5, that would be your other vertex. Again, I know that these are completely visible, and you may, just get them right from the graph. I just want to teach you this technique and reinforce it so that when we get to the harder problems with the radicals where you're adding to your x and your y value, you have the skill of knowing how to do that. Okay, so you have your 2 answers, which you can squeeze in there, but I'm just going to leave them there. Okay, moving on to example 4. Okay, and in example 4 it says if the center of an ellipse is 3, -4, and the major axis is parallel to the x-axis, and the distance from the center of the ellipse to its vertices is 5 units, then the coordinates of the vertices are what? So for all of these, when they start giving them to you in words like that, the best thing is just to take what they're putting in their little description and bring it down to the graph and draw it. Just go plot those points so that you can visualize what they're asking and what the answer is. Okay, so let's plot 3, -4. This will be 3, and then this will be -4. Okay, so 3, -4. This means the center is no longer at the origin. Instead, they decided to give you a center right here. And I'm just going to make this look like a big C for center, because you use little c when you're talking about the distance from the center to the foci. Okay, next piece of information. Distance from the center of the ellipse to its vertices is 5 units. Then the coordinates of the vertices are, now we have to pay attention to this comment that was made in the very first sentence. Major axis is parallel to the x-axis, because they are telling you which way to move. Because some students would be right here at the center, and they see that they have to move 5 units, and they become confused about, hey, should I move 5 units up and down, or should I move 5 units to the right and to the left? This A value is associated with your major axis, always your major axis. And if they're telling you that that major axis is parallel to the x-axis, that means that you should move in a horizontal direction. You're going to move the 5 units in order to build your major axis, because the A value is associated with that axis. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you can just do it like that by sliding your finger in order to tell what these vertices are. To get to one vertex and to get to the other vertex. Sure, that will give you the answer. And then you can just read off the coordinates. So yes, this would be, and we moved 5 units. We were at 3 and we moved 5 units. So 4, 5, 6, 7, 8, which you could just add. And you can put the center right here. This was 3, -4. So you're down 4 units here, and you moved 5 over, so you're at 8, -4. Likewise, when you go to name this vertex here, you were at 3, but you moved 5 this way, that's -2, and you're down at a depth of -4 for this point, because they're all lined up at -4. Again, I want to reinforce you being able to understand which coordinate do I mess around with respect to my starting point or my home base. Here we're starting from 3, -4 as our center. They told us that the major axis was parallel to the x-axis, meaning that if I want to act out this distance of 5 units, that I should be moving horizontally. I should be moving this way because of this comment. That means if you're going to be moving horizontally, anytime you're moving right and left horizontally, you're impacting your x coordinate, not your y coordinate. They're telling you how many units to move. So moving to the right, you always add. Moving to the left, you always subtract. And it is only your x coordinate that you're impacting. So if you're going to be learning to do it like this, which you need to, so that when you get to the end of the section, you can handle this. So just take the 3, add 5, you get an 8. Take the x and subtract 5, and you get -2, while leaving the y coordinate alone. So you can see this on the graph, but you can also just calculate it algebraically like that. Okay, so 2 answers here are, again, what you can see in the graph as well as me doing them here. This is one vertex and this is another one. I don't believe it'll matter which one. I mean, typically they list the one that is furthest to the left first and then they give that one, but I believe they'll mark it right either way probably. Okay, so that's all that was asked for in that particular problem. Let's move on to example 5. Example 5, it says, if the foci of an ellipse is -3, 3, and 5, 3, Okay, now they're giving us the foci, so you should plot those points and label them. Then what are the coordinates of the center of the ellipse? Remember, the center of the ellipse is the midpoint between the two foci. It also happens to be the midpoint between the two vertices on the major axis, which is where the foci are located. So let's go ahead and plot these. So -1, 2, 3, and then up 3. 1, 2, 3. Okay, so you have -3, 3. That's one of your foci. And then we also have 5, 3. So 1, 2. Make sure and label this. 1, 2, 3, 4, 5. This will be 5. And we're 3 up in the air. They're always lined up. And this will be your other foci. And they just want to know what the center is, which again, you could just count it out with your finger. And, if it's nice integers, it's easy to do that way. Or you can find the midpoint. You could use the midpoint formula. That's up to you. If you use the midpoint formula, whenever you're trying to find the midpoint of a segment, you add the two x's when you want to, because a midpoint has an x and a y. So let's say we wanted to find the x coordinate at the midpoint. You would add the x's, -3 plus 5, and then cut it in half so that you end up midway between the two ends. So that would be 2 over 2 or just 1. Okay, if you wanted to find the y coordinate at the midpoint, then you would add the y's. 3 plus 3 is 6. And then you want to end up halfway in between these 2 points. That's what midpoint means. So that would be 6 over 2 or 3. Okay, that means the center, which is really at the midpoint between the two foci, is at 1, 3. Or you can just count it with your finger. You could just go like this if you want to take a graphical approach. And sometimes that's easier than other times when the numbers become a little trickier. You could just say, okay, from -3 to 5, that's 8 spaces. You want to just use the graph to get this answer. It's 8 spaces. Half of that is 4. That means the center between these 2 points, located between these points, would be 4 spaces from either end. So you would just go 1, 2, 3, 4, and right there is the center, which is, notice that it's this answer that I just got here. It's 1, 3. Okay, I just did that problem for you algebraically as well as on the graph. Okay, moving to example 6. In example 6, it says analyze the equation, meaning find the center, the vertices, and the foci of the ellipse as well as graphing it. So we have to do all these things, find the center, find the vertices, find the foci. Okay, let's start by looking at the a squared and the b squared value, which gives us a and b. Okay, this has to be a squared. It's always the bigger one, bigger denominator. And if a squared is 81, I'll move this over here. That means a is equal to 9. This would be the b squared value, the smaller denominator, and therefore b is equal to 5. Just take the square root of those squared values because they appear in their squared form when they are introduced as the denominators. Notice that the a value is associated with the x expression. Therefore, you will move 9 units in a horizontal manner. Notice that at the top, there is no x minus h, no x minus any value squared, and neither is there in the y expression. Therefore, your center is at the origin. Okay, so we already have that answer right there. And from the center, we're going to move this a and b value. we are moving this value of 9 in a horizontal manner, again, because it's associated with the x expression. So let's see. How can we count out? I think we have enough distance to just use a scale of 1. So this will be 3. I'm not numbering every single one just because it will get, all the numbers will be crammed in. Okay, so give me a second. 7, 8, 9. So this will be 9. Okay, so right from here, we're going to go and plot one of my vertices. This is the center. And then I'm going to go 9 the other way as well. So again, this is 1, 2, 3, -3, 4, 5, 6. I'll just label them every so often. 7, 8, 9. And this would be our other vertex. Okay, then we use our B value, which is 5. And we're going to go up 1, 2, 3, 4, 5. And this is what we call a covertex because it's on the minor axis. When they ask you for the vertices, they're typically talking about the vertices on the major axis. So 1, 2, 3, 4, 5. But just in case they want these as well, these are called covertices on the minor axis. And then you can just connect them. So this would be the graphing portion. Okay, then we have to look for, and we already have our vertices. These vertices are, you can tell them on the graph. You can also count them out from the center. Again, I'm going to reinforce this method of figuring out which coordinate at the center to impact when we're getting to other important things such as the vertices. The distance from here to here, that's your A value. So if I want to slide over from 0, 0 to the right, that means that I impact the x coordinate and I'm moving a distance of A. So I'll write it like this, but in reality I'm adding a 9 because that's what my A value is. So 0 plus 9, 9. Do not change the y coordinate. If I'm going to move, and this is one of your vertices. When I'm going to go to the other vertice, again, I'm moving horizontally, so I'm impacting the x coordinate, but I'm moving to the left, so I'm subtracting this time. Specifically, what I'm subtracting is a 9 on my x. So this would be -9. Don't change the y coordinate. I know you can see that perfectly just by looking at it in the diagram. Okay, then as we go to find other things, so we found this, we have graphed it. The only thing left is for us to find the foci. And the foci are located C units from the center on the major axis. Okay, so notice that for the first time in this problem, you're asked to find these foci. So you need to know what is the distance C, and that's where the other formula comes into play that I introduced in the first couple of theorems. The relationship of A, B, and C. Starts like this. Has to do with the Pythagorean theorem. If you want to relate it to a right triangle, I would just memorize this formula. Go put in the values that you do know. We know that b squared is 25. You can pop that right in there. We also know from the original equation that a squared is 81. But we need to know c squared. So if we wanted to know c squared, we would move this over here, at which point it would become negative 81, and we would end up with negative c squared is equal to 25 take away 81 is negative 56. And then if we were going to divide the negative right off of there, we would end up with c squared is equal to 56. And after that, we would want to solve for c, so it would be removing the square by taking a square root from both sides. You are expected to know how to simplify square roots that only have a partial root. They're not perfect squares. Perfect squares are numbers like 64, square root is 8. 81, square root is 9, but this only part of it comes out, so you have to know how to break those down. Decimals are not acceptable. All right, so let's see, I believe 4 goes into this. If you divide 4 into 56, you get 14. So there we go. And if you break down 14 any further, you're just going to get 2 times 7, both of which are prime numbers. Therefore, you're not going to get anywhere, even if you do break this down further. So we're going to take the square root of this, which comes out as a 2, while the 14 remains inside. And that's what C is. So now, when we try to actually give these foci the coordinates of the foci, remember what I wrote right here. The foci are located C units from the center. So you're going to start at the center. You're going to stay on the major axis. Well, you can see that this is the major axis. So stay moving on that axis in order to move out to the foci. So we are moving horizontally. Therefore, we will be impacting our x-coordinate at the center. So coordinates of the center, again, were 0, 0. So when we try to move this way, we're going to be going x, the x-coordinate. Anytime you're moving to the right or to the left, you're impacting the x-coordinate. This time we're moving a distance of c in order to get to the foci, either one of to get to each one of the focuses. So you are going to be going, the c value was 2 square roots of 14. Well, when added to 0, you just get 2 square roots of 14, while the y-coordinate stays the same. If you're going to be moving this way, you're taking your x-coordinate at the center, and you are subtracting the c value. So this time we're going to be going x minus 2 square roots of 14. So that would give you the other foci as because we're subtracting, we're going 0 minus 2 square roots of 14, which is negative 2 square roots of 14. And then the y-coordinate stays the same. Okay, so we have found everything that we've been asked to find in this problem. We started off by finding the center. Then we recognized what the a squared versus the b squared value is, associating the a squared value with the x-axis because it was part of the x expression, causing us to move out 9 in both directions. We used the b value to move along the minor axis. We then calculated from the center the 2 vertices. We used the expression b squared is equal to a squared. You'll be using that a lot. B squared is equal to a squared minus c squared to find the c value, which helped us get to the foci. Right? Moving on to analyze the equation for example 7. In the equation that you're given here, we have 9x squared. It's not in fraction form, so it is your responsibility to get this equation to look like this. The only way you can truly tell what a squared and b squared is and then go on to find all the other values is when you have a 1 on this side. So whatever the constant is on this side, you're going to transform it into a 1. So very easy. We have a 9 there, and if we want that to be a 1, we divide this side by 9, which means we have to divide this side by 9. Everything on this side. So this gets divided by 9. This gets divided by 9. That now takes us into 9 divided by 9 is x squared over 1. You want to write these in fraction form. Y squared over 9, no way to reduce that. And then over here you have a 1. Okay, so now we have it as x squared over 1, y squared over 9. This becomes your a squared value because it is the larger denominator. Therefore, a is equal to 3, and that depicts the y-axis. This is not shifted. Otherwise, it would up here it would say x minus something, then with the square attached to the parenthesis. So this has to be the major axis, and our center is going to be right at the origin. This has to be your b squared value. Therefore, b is equal to 1, and this is the minor axis. Okay, so we can begin graphing. Here's my center. I'm going to move out 3 units. And note, again, pay attention to the fact that this a value was found underneath the y expression. It's denominator of the y expression. So you're moving this distance in a vertical manner along the y-axis. So I'm going to go up 1, 2, 3 right here. And then we're going to go down 3. 1, 2, 3 to negative 3. So we just moved our major axis. Also, keep track of the fact that this is the a value and this is your b value as you're graphing these. Okay, now along the minor axis, we're going to go out 1 and to the left 1. And then you can go ahead and connect those outer points to get your full ellipse. Now this is a very tiny ellipse. So I'm going to be doing the values for the foci. Let me not make this so big. The foci are going to be on the major axis, c units from the center. So the center was 0, 0. And if you're going to work off of that center to get the foci, you need to know what the distance c is. Okay, so the distance c, again, we're going to practice finding the c value by using the formula that I introduced in the last problem. B squared is equal to a squared minus c squared. Always start with that formula. Okay, b squared we already know. It happens to be 1. A squared we already know. It happens to be 9. We're looking for c. So that means we're going to bring this over here, at which point it becomes a negative 9. So you're looking at negative c squared is equal to negative 8, but then you divide that negative 1 off the c squared and end up with c squared is equal to just 8. So when you go to find c, you're just taking the square root of the 8 as well as the c squared. This erases the square, and you have to take a partial square root here. 8 is the same thing as 4 times 2. The 4 you can actually take the square root of. It comes out as a 2 by the time you take the square root. So this came out of the square root. This stays inside. So square root of 8 is the same thing as 2 square roots of 2, and that is the distance that we're going to be moving from the center out to the foci. We will be moving in a vertical manner because that's where the major axis is. Okay, so starting from the center, which is 0, 0, realizing that we need to move along this major axis to make it to the foci. So that means we're moving up, and therefore you're impacting your y coordinate. When you move up, you're adding, and you are adding the distance of C that we just found. So we're going to go the y coordinate plus the C value. Okay, giving us this, let's just put F, because I don't really need to spell it out. So to give us one of the foci, so this is going to be, leave the X alone, and then list how the Y coordinate has changed, which would be 2 square roots of 2. Okay, it was 0, we added 2 square roots of 2. And then if you want to move down, this time you're going to take the Y coordinate and you're going to subtract to the C value, 2 square roots of 2. So leave the X alone, take the 0 that you had at the center and subtract 2 square roots of 2, which would be 0 minus this, just negative 2 square roots of 2. Okay, so we now have the foci above and below the center. And those would be located, if you wanted to know approximately where they are, you could put in your calculator 2 square roots of 2 if you wanted to plot the point. 2 times square root of 2, just to get an idea of where to plot it, almost at 3. Okay, so 1, 2, so just almost, it's right before you get there, right before you get to negative 3. That's one foci, this is the other foci. This is the one where X is 0 and it's positive 3.8, which is 2 square roots of 2, and this is the one where it's 0, negative, or 2.8, sorry. This is where it's 0, positive 2.8, and this is where it's 0, negative 2.8. You just can't give decimals as your answer. You can just put them in your calculator, though, to help you figure out where to position your foci. But I believe if you are asked to graph this, you would have to actually type it in my math lab. Okay, that's number 7. Okay, in problem number 8, it says find an equation for the ellipse. Graph the equation. The center is at 0, 0. So I'm going to go plot that. It says the foci is at 8, 0. Probably shouldn't make this so big. Okay, so the foci is at 8, 0. So we're going to move out 1, 2, 3, 4, 5, 6, 7, 8. And the other foci would be this way. 1, 2, 3, 4, 5, 6, 7, 8. And remember that what they're giving you when you go from the center to the foci, that distance is defined as C. So we happen to know the C value. We also are given the vertex, which is at negative 10. So if this is at negative 8, this would be negative 10 right here. And therefore you'd have a vertex at positive 10. Okay, give me a second. Sorry about that. I had to turn something off. Okay, so we actually also know our A value. Okay, they'll always give you a way of knowing two of those three values so that when you go to use that formula, B squared is equal to A squared minus C squared, you have at least two of them so that you can find the missing one. So then notice we want to write the equation, yet we need A squared and B squared. So I showed you what you have here, and then we can use this formula again that we've used in the last couple of problems. B squared is equal to A squared minus C squared. We can go ahead and take that C value and square it to get 64. We also have the A squared value. It is, we have 10, but if we square that, that would be 100. So 100 minus 64 is 36. That would be our B squared value. And so we can go ahead and write the equation. Graph the equation, type the equation. Okay, and we can go ahead and type the equation right now. I don't know if I can fit it all in there, but we're going to have an x squared expression. We're going to have a y squared expression. Just make sure you get the a squared and the b squared in the proper denominator location. Okay, so our vertices are horizontal. This depicts the A value. So that A squared value of 100, since it's on the horizontal axis, goes right here. The B squared value of 36 would be associated with the minor axis. And so the last thing you'd need to do, we already have this equation, would be to complete the graph, because they've asked you to also graph this equation. So when you go to graph this, if b squared was equal to 36, that means b is equal to 6. And the values in their linear form is what we use for the actual graph. So this would be 1, 2, 3, 4, 5, 6. For a vertex on the minor axis, 1, 2, 3, 4, 5, 6. For a vertex on the other vertex on the minor axis, and then just connect all those vertices. Okay, and now you have the graph and you have the equation. Okay, moving on to example 9. Find an equation for the ellipse, graph the equation, centers at 0, 0, focus is at 0, negative 24, and the vertex is at 0, negative 25. Okay, so these numbers are pretty big. So let's see, I can design the x-axis. I think I'm going to, because we have to move so far out, I think I'm going to use a scale of 3. See if that would work. At least on my y-axis, because my vertex, look at the vertex here. See how that 25 is in the y position? That means I need to be able to move 25 spaces in either direction along the y-axis. This focus is always going to be on the major axis. The vertices, all of this is associated with the major axis. And being that these big numbers are in the y position, I need my y-axis to be able to handle some pretty big numbers. I am probably going to use just a scale of 1 on the x-axis because I don't have to move very far, I don't think. But I guess I can calculate that first. Okay, so let's graph what we do have. Okay, so I'm going to call this 3. Let me just show what my y scale is. This means every grid mark counts for 3. So 3, 6, I'll put them the numbers every so often. 9, 12, this would be 15, 18, 21, this would be 24, and then up here would be 27. Okay, likewise, going in the opposite direction, this would be -3, -6, just to pop some numbers on here, -12, -15, -18, -21. This would be 24, and then down here would be 27. If you let that go a little bit further. Okay, so if I did want to plot the numbers that they've given me, such as the vertex, the best you can do is just approximate this based on the grid that we have here. So 0, -25 would be down here. This would be 24, so 25 would be about there. And then likewise, you would have one at 0, +25. So this would be 24, 20. The other vertex would be located here. And then those foci are almost right on top of them. So 24, that's going to be your focus. And then there's another one at 0, 24. Okay, that's the information that they've given us, as well as the center, which is always the midpoint of the foci, as well as the vertices. It's in the middle of either one of those. It's just that when you're going from the center out to the vertex, that value is called A. So the distance from here out to the vertex is 25 units. When you're going from the center to the foci, that's called C. So I don't want to draw this in because it's just going to get messy, but when you're going from the center out to the foci, that's called the C value. Okay, and then we're trying to type an equation that has A squared and B squared in it. So we need to figure out what B squared is, just like we did in example 8 as well as 7. So we're going to go B squared is equal to A squared minus C squared. Again, we have 2 of the 3 values. We are looking for the B squared value. We have A squared. And then we're going to take C and we're going to square it. And this would be 625. And 24 squared is 576. And then when we subtract these two, it's 25 minus 576, you get 49. And if B squared is 49, then by the time we take the square root of B squared as well as the 49 that's on the right side, we have B is equal to 7, which we only need for graphing purposes. We're going to use it in its exact squared form, which is 49, when we give the equation. So we are actually ready to give that equation. I guess I can try to fit it in right here. It's going to be x squared over either the A squared or the B squared. We got to talk about that before we do it. Okay, so notice that this was the major axis, therefore the A value is associated with the Y expression. Okay, and that would be 20, no wait, let's write it in formula first. A squared would be here, B squared would be there. Okay, so then if you were to write it with the numbers, it would be x squared over the A squared value. Well, A was 25, so A squared is 625. And then Y squared would be associated with, oops, I did it wrong. Excuse me, I put the wrong one. Do that again. Supposed to put the B squared there. I wrote the formula and then did the opposite. Okay, so the B squared value was this 49 that we just got. And then under the Y squared value, we need our A squared value. So A was 25, and A squared is 625. And that's equal to 1. Okay, so there is our equation. And then to complete what they've asked of us is to give the graph, and so all we need to do is take the B value, which was this 7, use it in its squared form in the equation, but in its square root form when we're graphing. So we would have to go, my x scale, I'm just going to count in 1s on the x-axis because I don't have to go very far. I'm just going to 1, 2, 3, 4, 5, 6, 7, and then out to 7 the other way. 1, 2, 3, 4, 5, 6, 7. So right there. Right here. And then just connect those outer points coming from the vertices. Just connecting the two main vertices to the covertices. Okay, that completes numbers 1 through 9. I'm going to be doing numbers 10 through the end of this outline. I believe there are 14 examples, so I'll cover numbers 10 through 14 in the second video.